Hello and welcome to the series on solutions to IE Irodov's problems in general physics. In this lecture, we will solve problem number 3 of the book, which is related to the chapter motion in a straight line. The statement of the problem goes as follows. A car starts moving rectilinearly, first with the acceleration w equals to 5 meter per second square, initial velocity being 0. Then uniformly the car moves and then finally decelerates at the same rate and comes to a stop. The time of motion equals to 25 seconds. The average velocity during that time is equal to 72 km per hour. We are required to find how long does the car moves uniformly. Let's go ahead with the solution. The car has three stages in motion. First is uniform acceleration with initial velocity 0. Here the distance traveled in time t1 will be half wt1 square and the car reaches a velocity of wt1. The second stage is zero acceleration. Here the distance traveled in time t2 will be v into t2. The third stage is uniform deceleration with initial velocity not equal to 0. Here the distance traveled will be equal to x1 because the car is decelerating at the same rate as it was accelerating and the initial velocity is same as the final velocity of the uniform acceleration. Therefore, the average velocity of the car is 72 km per hour, which can be converted to give 20 meter per second. Now the total time of car movement is 2t1 plus t2 and which is given as 25 seconds in the problem. From this we can calculate the time the car moves uniformly and this is equal to 25 minus 2t1. Now average velocity of the car is given as 20 meter per second and this is equal to displacement over time interval. Total displacement is 2x1 plus x2 and time interval is 25 seconds. This gives 20 into 25 equal to wt1 square plus v1 t1. Putting the value of v1 equal to wt1 and t2 equal to 25 minus 2t1, we get 20 into 25 equal to wt1 square plus wt1 into 25 minus 2t1. This gives 500 equal to 5t1 square plus 5t1 into 25 minus 2t1. This is a quadratic equation and can be solved to obtain the value of t1 as 5 seconds and 20 seconds. Now 20 seconds cannot be the solution of this problem because the total time of motion is 25 seconds only. Therefore t1 can only be 5 seconds. From this we can calculate the car movement in uniform motion, that is t2. This is equal to 25 minus 2t1 and this is equal to 15 seconds. This is the required answer that we were seeking.